Hello there, I'm Thomas Hatsios. I'm an American pilot flying the Boeing 787-900. Tonight's flight we're going to be over from Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 1449, Lszh localizer landing, and landing in the cockpit for the pre-takeoff operation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display. That displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, theoretical rate of climate descent of the aircraft intents 1,000 feet per minute, or the stiffness of the trigonometric angles in decrease and can climb and ascend. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease and the bank angle decrease. The Lszh localizer, we have the horizontal localizer and the vertical glide slope. We have the Lszh localizer, the instrument landing system that transmits radio frequencies from the threshold antennas of the runways we use for takeoff and for landing. So we have a unique radio frequency to tune each time. We use a runway for takeoff or landing, and also magnetic north pole heading track for the runway. We have also we have the onboard antennas of the aircraft that receive the radio frequency from the threshold antenna runways, and we align with the horizontal localizer and vertical glide slope, which is the angle of approach. We have also the angle of attack of the aircraft as it flies, the flight director crossbars for manual guidance of the aircraft, the autopilot crossbars for automatic guidance of the aircraft, and the flight mode annunciator with the autopilot and the autothrottle laser and vertical navigation modes. We have also the HSI, the horizontal situation indicator, with the magnetic heading and track that displays also the degree display of the flight plan we use when we fly. So we create a flight plan or a flight path or route using the flight management computer. You can see here we have the flight management computer, the primary flight display, the navigation display, the ACAS, the engine indication controller system display, the autopilot flight director system panel, the thrust lever. So I will show you all the systems one by one. So we have the horizontal and vertical component here of the navigation display, as you can see. So I'll show you all the functions of the aircraft before we go in flight of the Boeing 787. So the navigation display displays the horizontal and vertical profile of the aircraft as it flies. You can see the terrain or weather reflections from the weather radar. You can see the red, green, yellow, and red, green, yellow and amber indication of the terrain around you, depending on the distance of the terrain, how far away it is from you, and also the altitude difference from the aircraft. Also you can see horizontal and vertical the terrain below you and in front of you when you fly. Also around you can see also the terrain. You have the GPS position of the aircraft. We have the terrain map with the airports, where the airports are located. Our own airport, the Lszh in Switzerland. You can see the runways, the taxiways, and the airport map also displayed in the terrain map, so we can use from the GPS. We can navigate in the airport. We have also the navigation aids, the nav aids, the road stations, ADFs, and the Bs. The waypoints which are horizontal and vertical navigation, fixes and altitude and airspeed constraints we have to fly through. Some waypoints we can select using the flight management computer, and we can fly either manually or automatically using the autopilot flight director system panel in the LNAV and the VNAV mode. The lateral navigation and vertical navigation modes you can see here. Also we can use in the navigation display, we have the magnetic north pole and geographic north pole magnetic variation depending on where we are in the world. We have also the display of other aircraft where they fly. Using the transporter, the ADSB and ADC transmitter receiver that transmits frequency to other aircraft, and the air traffic control and receives from other aircraft, and can display where the other aircraft is located. I can calculate from its computer the distance from our aircraft, the bearing from our aircraft. Also you can calculate the altitude difference between our aircraft and the other aircraft, how many hundreds or thousands of feet are above or below our aircraft. Also they can calculate whether they climb or descend with respect to our aircraft. You can also calculate The velocity closing in between aircraft and the other aircraft will give us a warning from the TCAS system, the Traffic Collision Advisory System, to make an avoidance maneuver in the air. Also, you can see we have the display of the aircraft with a diamond shape in the navigation display, and also we have the display of the aircraft in the runways and the taxiways, and from the TCAS system. So we have also the engines indications, the autopilot flight director system panel. You will see the thrust levers, the flight controls. So I'm using this Logitech Extreme 3D side stick, which is identical to the Airbus side stick. I'm having this also, the mouse pad and the keyboard to control the inputs I need to do in the flight management computer here, or the autopilot flight director system panel, or other switches. You can see the overhead panel or other panels. So I'm gonna show you how to control the flight controls of the Boeing 787. So I have this Logitech Extreme 3D side sticker control the yoke, so we can climb and we can descend. We can make turns to the left and turns to the right very fast. You can see how accurate is the side stick deflections. Also, you can see the rudder pedals. I can make left and right rudder turns, or the nozzle steering control. Also, we have the toe brakes over here in the rudder pedals. We have also the tiller for directional control. So we climb. I have the side stick back and forth in the Airbuses. Climb and descend. Also, you have the control column or of the yoke to climb and descend in the Boeing aircraft. Also, we use the control wheel over here. Is the side stick left and right in the Airbuses. The control wheel left and right in the Boeing aircraft. No difference. All flight controls are the same. Also, we have the thrust levers. You can see I move the thrust control here, this slider, so we can increase and decrease the engine thrust. Over here we see what percentage we have. Over here you can see we're not configured for takeoff, so it gives us a warning when we increase the engine power above the limit. So we have the displays here. I'm gonna show you. So also we have the horizontal trim stabilizer here. I can trim the horizontal tail like this, pitch up and pitch down. I have also this trim switch over here, and the cutoff switch for the stabilizer trim, you can see here. So this is the alternate pitch trim over here, which is part of the flight control system. You see how many degrees you pitch up and pitch down the horizontal tail of the aircraft over here, 4.25 degrees right now. It's preset automatically, and we can change that because there is an auto trim function from the flight control computers, and also a manual trim order coming here from this switch when we fly. So you can trim up and trim down the horizontal tail of the aircraft. As you can see, elevator trim, left click down, right click up. So this way is a trim up, elevator trim, left click down, right click up over here, and this way you trim down. So when you trim the elevator up, you pitch the nose of the aircraft as you fly up, and when you trim down the elevator, you pitch the nose down as you fly. We have also the autopilot disengage over here switch, and the head up declutter switch over here. So I'll show you the flap speeds also. So we have over here is the alternate trim switch, pitch trim, elevator command. So you see elevator trim, left click down, right click up like the other. Also we have the cutoff switch. I will talk to you in a couple of seconds. Also we have here the speed brakes, extend and retract like this, and also the flaps position, which is part of the flight controls. You can extend or retract the flaps of the aircraft. You see how many degrees you have here. So I will talk to you now about Newton's physics, aeronautical and aerospace engineering. It derives some principles we need to know for flying the aircraft. For the air transport pilot license, the commercial pilot license, we need to know the aerodynamics of the aircraft, flight dynamics, and also the Newton's physics movement theory of fluid, and some other principles. So I will show you the outside view of the aircraft and show you also the flight controls. I'll use the side stick to control the flight controls using the aerodynamics of the aircraft like this. So you can see here we have the flight controls again: climb and descend, make turns left and right, the rudder pedals also. So this is the outside view. I'll talk to you about aerodynamics now of the aircraft. So you can see the surface area of the wings hold the weight of the aircraft as the aircraft flies. We divide the weight over the surface area of the wings, which produce the lift force that lifts the wings up and the weight of the aircraft up, overcoming the weight. So we need the aerodynamic flow of the air from the front, from the leading edge to the trailing edge. So we have the thrust that overcomes the drag from the engines that pull the aircraft forward. Push or pull the aircraft forward. So this is jet engine, it pulls the aircraft forward. You see the jet blast here, this vector. We have two vectors for two engines, one left, one right wing. So you can see we have over here is the high pressure compressor and turbine in the back section, and the high speed starter and shaft, the high speed spool, also the exhaust cone from the engine. Also we have the bypasser from the front fan, and also we have the combustion chamber, and also in the front section is the low pressure compressor and turbine, and the low speed starter and shaft, and low speed spool of the engine. So we can see also we have where the engine is suspended. We have from the wings we have the fuel flow from the top over here, these lines. We have also the wing and engine on the ice over here in the front side. So we have the front fan and also the bypasser from the front fan, and the high pressure, the compressor, the exhaust jet blast from the cone of the engines. So these jet engines, we have the aerodynamic cord over here, the Mach, which is about 23% of the aerodynamic cord, where the maximum aerodynamic lift occurs in forward wings, where the center of pressure also moves back and forth as we fly. Also we have the stall begins over here. The airflow becomes detached from the top surface of the wings as we fly. So in order to avoid the stall over here, you monitor inside the aircraft all the time. You can see the airspeed indicated over here, the airspeed table, and we have the stall speed is displayed just below the airspeed with a red and amber or yellow indication over here. So we need to avoid the stall of the aircraft. We push the forward the side stick in the Airbus or the yoke in the Boeing, and we apply more thrust to increase the airspeed. This is the stall avoidance maneuver. You can see later when we fly to exit the stall condition. So also where the aerodynamic cord is, where the maximum aerodynamic lift occurs, we have also the left wing and the right wing centered. We have 30% of fuel right now in the left and the right wing, and 10% in the center tank. The aerodynamic cord is also where the center of gravity is located for an airliner aircraft. So it's pretty much here is the yawing axis over here, so you can yaw the aircraft left and right turns. Like this, you have the directional control of the aircraft using the rudder when it becomes aerodynamically effective. Also to yaw the aircraft, we have the forward nose wheels over here. So we can deflect the forward nose wheels 76 degrees to the left and right side. From 0 up to 45 knots or 72 kilometers an hour in takeoff. Then as we increase airspeed above 45 knots, the rudder becomes aerodynamically effective, and then the computer decrease the deflection automatically of the forward nozzles from 76 to 7.6 degrees left and right. Then as we increase the airspeed in takeoff above 80 knots or 144 kilometers an hour, we have only the rudder aerodynamically effective using the rudder pedals. So the forward nozzle is locked to zero position, zero deflection, or a little bit like maybe half the degree. So we have only the rudder aerodynamically effective and high airspeed. So we have the rudder pedals over here. You can see we can control the rudder like this, make left and right turns. This is the rudder control, and also the forward nozzles control. But I talked to you the tiller also, left and right side for the forward nozzles. So it's very easy to control the rudder. I have it in my side stick, and also the nozzle control. Is the inverse when you land. You have first the rudder aerodynamically effective, then the nose will coming in as you slow down your airspeed. So when you take off, the nose will comes down, it decreases, and then deactivates from the computer. Then you have only the rudder, and now the inverse is happening in landing process. So we have also one more axis over here is the pizza axis of the aircraft from wingtip to wingtip. Is the side stick back and forth in the Airbus aircraft is the elevator up and down, climb and descent. Very easy to remember, very fast and accurate as you can see with the flight control system. So on the Boeing use the yoke to climb and descend the aircraft, pull up and pull down, climbs and descends. So it's also very fast as you can see. So you take the weight up and you take the weight down as you fly using the elevator, the horizontal tail of the aircraft. So side stick back and forth in the Airbus, yoke back and forth in the Boeing, same flight controls, no difference. Also we have one more axis, is the longitudinal axis of the aircraft from nose out to tail. Is in the Airbus the side stick left and right deflection. So you can use the ailerons and the spoilers in the Airbus aircraft to make left and right turns. You use the aerodynamic difference between the left and the right wing when you move the ailerons and the spoilers. Aerodynamic lift difference between the left and the right wing. So this creates a rolling moment. The aircraft to turn around its longitudinal axis. So in the Boeing you have aileron, spoilers and flaperons also. So in the Boeing is the control wheel like this. So we have also an aircraft is coming in for landing, as you can see. It's a Boeing 737-800. Here we have it. Just landed. Also you can see the longitudinal axis, which is the side stick left and right. In the Airbus is the control wheel in the Boeing aircraft. You use your control wheel like this, make left and right turns, no difference, same principle, very fast and accurate. No difference using control wheel or side stick. As you can see, is the same side stick and control wheel. Deflection, left and right. Also control column, side stick up and down. Also the rudder pedal. So we have all the flight controls, horizontal trim stabilizer, the horizontal tail of the aircraft. Also the nose wheel steering. So this is all the controls you need, flaps and speed brakes. Also the thrust levers over here. Actually the thrust. I will show you one more view now of the flight controls. One more view of the flight controls of the Boeing 787, and I will show you also the rest of the systems of the Boeing 787 before we go into a full manual flight. In the end part of the video we'll make also an exit style demonstration and set up the while matching computer in the autopilot. So I will show you all the displays and the functions of the Boeing 787 before we go into that section. So you see now this view of the aircraft over here. You can see again all the flight controls, all the side stick that I have. So we can make turns left and right and climb and descend. So we climb and descend the aircraft, the elevator over here. As you can see, we have the horizontal trim stabilizer also, so climb and descend. Make turns to the left, turns to the right, like this. Very fast and easy. Accurate. You can see both sides, the captain and the first officer in the Boeing aircraft are interconnected, move simultaneously. In the Airbus we have also other systems, so you can use an override force for the Boeing aircraft, so you move the slider back and forth. You see the engines increase and decrease like this over here. So we have also so this is the main flight controls. You have in the Airbus the side stick priority button. You can take priority to the left and the right side, push to talk, and disengage the autopilot over here. So this push to talk, disengage the autopilot in the Airbus aircraft. So we can see also we have also dual input in the Airbus. In the Boeing you have interconnected flight controls. You need to use override force from either side to use only one side. I can also show you also the outside view of the flight controls. You can see the horizontal trim stabilizer. I have it here. I can trim the horizontal tail, the thrust control over here. So this is all the functions. So the tail, the rudder, left and right, climb and descent, elevator. So this is very easy when you fly to control all the aircraft trajectory. So we have also aileron spoilers, left and right, side stick deflection like this. So hope you like my flight control system. So I'll show you now the rest of the systems of the Boeing 787. That was enough for the flight controls now. So you will see a couple of things more. We need to know the displays over here, the primary flight display, the navigation display, autopilot flight director system panel, also the flight management computer. I'm gonna set the flight management computer input all the data for the aircraft and create a flight plan. So I'll start with the primary flight display now, or maybe I can create the flight plan. So you will see now I have here the mouse pad and the keyboard of the aircraft, the screen. So I'll use this keyboard over here, and also the screen of the CDU, the control display unit, the mouse pad here to input whatever I need to create a flight plan. So we have the mouse pad here, and you can see the screens over here. You can use the index, identity, position, performance, takeoff, navigation data, load the traffic control, save plan, save flight plan. So I will show you the displays after doing that. So we go over here. We have control quadrant. So we have one more display for that over here. So we have the identity position. So the identity is a Boeing 787. Over here model, the index, we have the position, Lszh airport, Zurich International Airport in Switzerland. You can set the coordinates allowing the IRS of the air data computer of the GPS system. And also we have initialized performance, 0 fuel weight plus fuel on board, cross weight for takeoff, reserve, cruising altitude, cost index, fuel freezing temperature, cruising center of gravity. So we're gonna set that after we set the route here from Lszh Zurich International Airport over here back to Zurich International Airport, origin and destination. So we have the runway 14 over here, departures over here. We can select runway 10, 14, 16, 28, 32 over here. So we select the runway 14 and the Zui to Alpha. Let's see its departure. So we have departures and arrivals. We can select arrival approaches. VOM 16, 28, 34 ILS, 14 ILS, 16 ILS, 28 ILS, 34 ILS, 28 ILS, localizer 28 localizer 34. So we select ILS 14 trans Mickey over here. In the stars, the Sadar terminal arrival weapons and fixes. We use Negria 1 Alpha. So we have the route is displayed with blue, the legs, 1 waypoint after takeoff, 2 nautical miles heading, and also Zui, 6 nautical miles, climb to the Negria over here, descent approach to the Zurich 701 and landing. So we need to activate that. We use 0 fuel weight, 322.7 thousand pounds and 34.7 fuel on board, gross weight 357.4. So we have the reserve 5% for this flight. Cruising altitude 25,300 over here feet. Cost index 100%. Fuel freezing temperature, cruising center of gravity. So we have the active flight plan. First waypoint, we press this execute button here to activate the flight plan. The route. So we have first waypoint 250 knots, 1900 feet, 2 nautical miles from the runway threshold, 1 nautical mile 3. We make a left turn, 5 nautical miles, turn to Zui, 6 nautical miles heading 052, 301 knots, 6000 feet. Then Negria is 26 nautical miles from Zui, 301 knots, flight level 22,200, 301 knots. Make a right turn, Mativ 12 nautical miles with descent 320 knots, 11,300 heading 230. Keep 6 nautical miles, Amiki 9 nautical miles, Zui 6 nautical miles, Zik 701, 180 knots, 6,000 Alpha. Then TRA 10 nautical miles, CR14 6 nautical miles, Ozanam 5 nautical miles, runway 14 8 nautical miles. We make a left turn here to align with the runway as the flight plan says, and have this airspeed and altitude. So we use also flaps for landing, 15 degrees, center of gravity 23%, 4.25 degrees, and the takeoff speeds V1, we rotate V2, this gross weight and the runway position. So we need also route, departure, arrival, alternate, VNav. We have some other functions, progress, hold. We can hold over a waypoint in the air, FMC communications, fix, and navigation radio. We can tune ILS or localizer and ADF. So we go in the virtual cockpit again. So you see here so you see the view of the virtual cockpit. We need to do a few more things. I talked to you about the screens. Now you will see the horizontal trim stabilizer here, the elevator. You can see the tag, it says normal elevator trim over here, elevator trim. Right click down, left click down, right click up. So we trim the elevator up and down. We use also the alternate pitch trim, and we have the cutoff switch over here. We have the fuel control for the left and the right engine. We have the auto throttle disengage, the thrust reverse also here. The fire extinguishers for the left and the right engine, the transporter, radio and communication panel, radar trim over here. So this way, if you have a failure of the flight control systems, this is a fly-by-wire aircraft, you can see the flight controls over here. From the hydraulics, that will affect the hydraulic system, left and right engine, driving electric C1, C2. That will degrade. We have the flight control computers, the normal, the alternate, and the direct mode, like in the Airbus aircraft. If you have a failure, we're gonna lose the auto trim function from the autopilot flight director system panel. So the auto trim is important because the aircraft trims itself automatically. You can also use manual trim. So we have a failure that degrades the flight control computers, like in the Airbus aircraft. We have something in the Boeing we have to do. You see here we have these red guarded switches here that says cutoff switch. So we have a failure for Boeing 737, 747, 757, 767, Boeing 777, and Boeing 787. You open this red guarded switch from normal to cutoff, and then you lose the auto trim. You can use either left or right cutoff switch, as you can see, and you use only the alternate trim switch, which is manual. Over here, nose up and nose down, you trim the elevator for climb and descend the aircraft. We have also the parking brakes here, as you can see. Radio communications, VHF, HF, satellite cabin, ground proximity with the radar, satellite transporter. So we're gonna see now the displays and then make the engine start demonstrations. You can see here the displays horizontal trim, stabilizer, radar trim. We have the bleeder from cabin pressurization. Over here in the manual, you will see how it displays. The controllers, you can use either automatic or manual. So in the manual, they will display. Over here in the screen, you can see the engine's indication, left and right engine, and one exhaust gas temperature and two fuel flow, oil pressure, oil temperature, quantity, vibration of the two stages of the engine. We have also the cabin pressurization, differential pressure, cabin altitude. Over here, so you see cabin altitude, differential, rate of climb descent, the outflow valves position. So we're gonna pressurize the cabin. Differential pressure is gonna be 7.8 or 8 psi. It's gonna be automatically when we climb with descent, also with the pressurized. So you can see here we have gross weight for takeoff, total fuel on board, the fuel temperature right now. Also gonna be flying over. You can see the displays also. Also here we have the landing gear extend and retract, the alternate gear, the lock override, and the retract and extend speed for the landing gear, the auto brakes. Over here you can set automatic braking, reject the takeoff. It will display in the screen auto brake set RTO, or we can set when we land auto brake 1, 2, 3 position or max, as you can see. So we're gonna set the rest of the systems, the screens over here. Before we make an engine start demonstration, you can see here we have this screen, the primary flight display. It displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, barometric altitude above the sea level, the barometric pressure of the outside atmosphere. So in order to set the barometric altitude over here, we need to come in this display over here, the FS panel, and set inches of mercury or hectopascals. So right now it's 29.9 inches of mercury or 1013 hectopascals. You can switch either or increase and decrease the value. You will increase or decrease your altitude, barometric altitude. Also we have the radio minimums, baro set. We have the displays here for the map, plan menu, rates, weather radar, traffic and terrain over here for the map display. So you can see here we have the barometric pressure altitude set 29.92 inches of mercury, the radio baro minimums or radio. We have also barometric altitude. You can see with the pitch ladder, the airspeed indicator, airspeed and also barometric altitude selected. We have the pitch ladder 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down. The pitch altitude of the aircraft in the air. We have the bank angle in degrees, like 5, 10, 20, 30, 45 degrees, bank roll left and right. Also the rate of climb at the center of the aircraft, the vertical speed indicator. You can see 500, 1000, 1500, 2000, 3000, 6000 feet for climb or descent. The radial altitude above the ground level 2 feet. It will display like 2500 feet. You can see also the vertical, the radial altitude over here. We have the flight plan displayed here and here, horizontal and vertical. So we have the crossbar switch for the flight director. Right now you can see also the wings level of the aircraft, the takeoff, go around, fly mode and zero. So you can see the airspeed 200 knots, the heading and the altitude is the same as values as selected from the autopilot flight director system panel. So we're gonna set the view here. Later you can see we have the Düsseldorf airport over here. Here is Germany. Here is France. You can see the terrain level 4900 over here with red, and with amber is 1600. The Zurich International Airport. Also the flight plan, the vertical. You can see how far above the ground we're gonna be flying with the aircraft, how many thousands of feet in the air. You can increase and decrease, see other things also. See the center display. You can see also the runways. If you look up closer, you see the GPS position, the runway we're gonna use for takeoff and for landing here, and the taxiway, the other runway, as you see from outside, the terrain, also the mountains in front and around you, other aircraft, other airports, navigation aids. So we have the terrain and map over here, the weather, the flight plan. You can see the stars, the waypoints we have to fly to, vertical or horizontal. So I'm gonna show you now over here the overhead panel. We need to start the APU now because we're gonna make an engine start demonstration. Start the APU like this. Primary flight control computers in the auto. So we have left and right IDG over here, pressurizer over here in the auto position. We'll start the APU. We have 120 200 volts, 400 Hz frequency. The contactors drive disconnect if we need primary flight control computers in the auto position. Also battery, APU generator over here, air data computer, flight control surfaces over here, battery down with power, FD door, passenger oxygen over here, window heat over here, rammer turbine backup for the hydraulics, left and right engine, hydraulic pumps we can turn off like this, and you see what it displays. We can turn back on again or in the auto position. So we turn first on, then in the auto. We have the electric also, C1 and C2 hydraulics. So we have the wing and engine got the eyes over here very quickly in the auto or on position. We have also pressurizer from the engines or from the APU. We need for cabin pressurization over here. Wing and engine got the eyes, hydraulic fluid tanks pressurization, also for the oxygen and ventilation of the aircraft. So you can see the pressurization. We have the automatic controllers. We can use the manual. We can use the outflow valves for pressurize or depressurize the aircraft when climb descent and select the landing altitude. Also we have over here the recorders. We have the cargo and APU fire over here. You can see we have electronic engine control for the engine with the normal and alternate mode that control the fatics, the electronic, the fatics, the fuel authorities, the electronic control computers. We have the auto start. Over here we will start the engines. We have the fuel jettison. We can make an emergency landing over here, dump some fuel in flight if we arm the switch and select the nozzles, and over here how much fuel to remain. Also we have the fuel booster pumps, the left wing and the right wing, and the center tank. The crossfeed valve is off. We turn it on. You can feed either engine with either pump or either tank and balance. Over here the fuel between the left and the right wing. So we use back the valves, fuel booster pumps, and the balance over here. So this is how you control these things. Also you can see, so this is the main components. We need to make an engine start demonstration right now. I will set up also the autopilot. I'm gonna show you first the displays over here. You can see the systems displayed with a digital format over here. So all the systems you see in the overhead panel, you can see the hydraulics, the APU is running, the data of the APU, the oxygen and liquid cooling, the pressure of the oxygen. So we have left and right IDG, the great drive generator, the APU is running. This is the electric system, the load set. So this is 120 200 volts, 400 Hz breakers, and the main battery and the APU battery, the voltage and the average if they charge or discharge also. Other data, so we have 100 to 200 volts, 400 Hz breakers, 130,000 kilovolts. The hydraulics, where the hydraulic fluid goes, which system is used. Primary demand, left and right engine driving, electric C1 and C2. The pressurization 5,100 psi for the hydraulic fluid from the pumps and the pressurizer. The fuel system also, you can see we have the left and the right wing fuel tank 11,000, the center 11,000, total 33,900. The long high pressure fuel valves, left engine, right engine, both open and feed both engines. You can see the fuel line from the center or the left and the right wing. The crossfeed valve is off, but we turn it on. You can feed either engine with either pump or either tank. The APU is fed from left wing using the DC motor over here. You can see forward and aft fuel booster pumps. You can see the minimum fuel temperature below which the fuel will freeze down here. So we need to recirculate the fuel in many aircraft automatically from the fabrics. We have the fuel recirculation and transfer. So you can see minimum fuel temperature right now is minus 37 degrees and the fuel temperature right now minus 6. So when we fly higher altitudes, the fuel will freeze. So the fabrics transfer, they recirculate the fuel from the wing, left and right wing tank and the center tank into the engines components to heat up the fuel, and also is doing the same for the lubricant and the oil. So we have the air pressurizer from the engines and from the APU, cabin pressurization. The doors are closed. The gear, you can see the pressure of the tires and the temperature of the brakes. Also the flight controls over here, so we can make turns, left and right turns over here. Also the tail of the aircraft, the rudder. So this is one of the last things we need to see over here for flying the aircraft. As you can see, the flight controls. We're gonna make the engine start demonstration in a couple of seconds. So we have FS display over here, maintenance over here, system circuit breakers over here. One last thing left is the checklist over here. We have the normal menu, before start, after start, before takeoff, after takeoff, descent, approach, landing. We have also communications and navigation display again. Also in the navigation display you can see a little bit further off, you see more airports, you see more blue letters here, more airports, Germany, France, Switzerland. Also we can look the other plan here, map centering, as you can see. You see map centering here. The flight plan we have created. Also you can see the aircraft position, the runway. If we look up closer and closer, so you see where the aircraft is located right now in the terrain map, the GPS locator, and the inertial alignment. You can see also the runway. So this is what we're gonna use. We're gonna turn off both engines right now, fuel control to the off position. So you can see here we have the fuel starvation message. The engines are off over here. So we look outside. So this is the aircraft. I'm gonna make an engine start demonstration over here. We need to restart the auto start system very quickly in the start position, both engines over here. You can see the reconfiguration amber switches color lights. So we have only pressurizer right now into the engine. So this is the N2, which is the high-speed starters have high pressure compressor tube, one of the turbofan tube of the engine receives a pressurizer. So you can see we have pressurizer right now. So we can let the fuel control both fuel valves on like this. So we have now both fuel and pressurizer. You can see the auto start is turning on. You can see also the N1, which is the low speed starters have low pressure compressor to one of the turbofan tube engine. It's also the outside view. The N2, which is the high speed starters have high pressure compressor to one, the exhaust gas temperature, fuel flow, oil pressure, oil temperature, quantity, and the vibration of the N2 stage of the engine. So above 61%, you will see running engines, 62. So here we go. Flaps for takeoff over here, speed brakes up. So we can set up also the autopilot flight director system panel very quickly. You will see what it displays. We have the auto throttle left and right over here. As you can see, on and off, if we set up the autopilot and fly, the airspeed, we can use lower or higher airspeed in the air. So this is the airspeed guidance of the aircraft. You will see later when we fly the LNAV, the VNAV function, which takes controls from the flight management computer, flight director on and off. If we turn on or off, we cannot rearm. We need the flight director on. Autopilot disengage. This is the engage autopilot and disengage like this, very fast. Flight level change, auto throttle climb continues. Heading over here, bank angle and heading. So we set the heading over here, same like the runway you're gonna use for takeoff. Also vertical speed, we can level off like this in the 0. We can descend with a minus sign, how many thousands feet or angle, and also we can climb. You see the plus when we have a climb rate like this. So we can set also the altitude, set thousands and hundreds. So the autopilot is ready. We take the air traffic control clearance for the aircraft, so we can taxi into the runway. Parking brakes off like this, advance the thrust levers forward, and we go for takeoff. So we see the runway is open for us. We can use it for takeoff. So we align with the runway center line over here. We use the tiller like this. We brake a little bit and use the tiller again. Advance a little bit the thrust levers. So we align with the center line like this. You have to remember the aircraft is having 200 feet length almost. This may be 150, so we align with the center line. We advance the thrust levers to take off ground position like this, as you can see. And we press the yoke down or the side stick until 80 knots. Also we use rudder for directional control and the tiller, as you can see. So we have 80, 90, 100 knots, 120, 130, V1, we rotate slightly, like 9 degrees, and we take off, as you can see. So this is the positive rate of climb of the aircraft. We have landing gear up over here. So we can see flaps a little bit up. So we are 1000 500, 1700 above the ground, almost 2000 feet above the ground, about 3800 above the sea. The airspeed is 180 knots. You can see the terrain with red, green, yellow, the mountains and the valleys, the flight plan. We have to follow the aircraft above the terrain, so we climb with 5000 feet per minute. The stall speed, yellow and red, the wind direction and speed over here, so we keep climbing over here. So we can see also, if we look closer, also the engines over here, indication, and also you can see the terrain below you, or so you can see the terrain is this green line over here, down here, and you can see the distance. You can see the aircraft is like 4,700, 800. It keeps climbing 4,000, 900, 5,000 feet right now above the ground. You can see the distance in nautical miles also in front of you, like in the original aircraft. So we keep climbing. Also, don't forget the airspeed. So we're gonna have to make the turn now. Over here, keep climbing from the airport. So we make the turn over here. So you can leave the hands off from the side stick of your aircraft or the yoke, no problem. It keeps turning or it keeps leveling off as you like it, as you control it to be flying. Only the aircraft can do that, an airplane. So you can leave the hands off, no problem. You can see we keep flying the way we leave it. So you can see the runway down here. We just climbing. You can see the air data. Oh, we have a beautiful view over here as we depart the airport. So you can see the Boeing 787 over here as we climbing. So you can see we keep climbing over here, and the airspeed, the stall speed, flight director on. Look a little bit closer over here, the flight plan we have to fly through. So this is very beautiful view over here as we depart the airport. The Switzerland, the lakes, the Swiss Alps, the aircraft, the Boeing 787. So we're gonna have to fly over the Germany and the France in a couple of minutes. You will see. We have also other traffic, other aircraft over here. So we have to be aligned with the Zui, this waypoint over here. Maybe we have some time we connect the autopilot, so you will see that the autopilot works in the Boeing 787. We use the LNAV right now over here. So we're gonna be aligned with this line. We make a small right turn over here. Hope you like the beautiful view over here of the aircraft. So we have We have to be aligned now with this flight plan, all the air data. You can see now. So we have the airspeed here, the flaps. Warning, we have the stall speed is 120 knots approximately, the wind direction speed. So we're climbing with this altitude right now. Over here we have to follow the flight plan through this line. The next waypoint here we need to follow is the Nigria, as displayed. You can see the ground speed, the distance, the engines indication, the flight management computer over here. Also the autopilot flight director system panel. So I may engage the autopilot here, as you see how it works. So we use the auto throttle and the autopilot engage like this. We press the switch over here and we have the autopilot commanded now. As you can see, autopilot. So we'll set the values we have set over here for the autopilot commands. You see autopilot engaged here with the LNAV and vertical speed. We're gonna climb to 25,000 feet like that, as you can see. So this is the outside view. You can see the Germany, the France, my homeland Germany, the Bayern Munich and the lake. We need to start also taking the turn now. You can see also the chemtrails. So maybe I decrease the autopilot now, because we take a steep turn over here. We don't need to make so much steep climb, and to fix that. So we can take the autopilot again, the engage, after we exit the stall. So we may engage again and also use the override over here. We're gonna use from the Nigria. Gonna fly over another waypoint over here like this and press the execute. It will turn us back to this waypoint, the Mati. So now we make a turn using the autopilot engage. Also we can decrease the rate of climb like this. So this is how to take the turn over here, overflying these waypoints. I'm going to disengage the autopilot now and use full thrust, full manual thrust over here. So now we're flying manually again without the autopilot. So we take the turn over here, we overflying Germany, France, and going back to the airport. So we leave behind the lake, on the Germany, and we're going back into the Switzerland area. You can see with the auto throttle the airspeed is decreasing because it didn't apply full thrust for climb, so I had to use manual thrust again and disengage the autopilot. So we keep climbing back to 22,000 feet, 23, then we're gonna make descent back to the airport. So we cross over here this altitude. You can also see the view from the cockpit over this side. So we keep climbing. We're gonna cross through this area over here. We're flying manually right now. So you're gonna see the chemtrails in a couple of 400, 500, 6, 7. So here we have the chemtrails, as you can see. So this is the most beautiful view we can have here from this aircraft, overflying the Switzerland over here, the Germany behind us, the Bayern Munich, my homeland, and the France in this side. You can see we can level off with the flight controls. So we'll make a couple of turns over here. And we're gonna start descent and approach over a minute. Hope you like this magnificent view. 22,000, 23,000, 24,700 actually. So we're gonna start the descent for approach now. Idle thrust over here. Flaps retracted. And increase the rate of descent, also the speed brakes over here extended. So we're descending now, as you can see. We need to pitch down again as we descend. So keep descending. You can see we need to enter these waypoints for approach and landing over here. Decrease a little bit the airspeed. Increase the rate of descent like this. You can see we keep descending. So we have the airport here. You can see the approach points we're gonna use. You can see them also on the map. So we're gonna start the turn now. Over here as we descend, make the turn of the aircraft. Idle thrust now. We go in manual. We keep descending over here. So we see we have 3 more minutes. Keep descending over here. So we need to be aligned with the runway heading. Over here you can see this mark. Keep descending, increase the rate of descent. So we have the runway, almost overshoot the runway. We use left rudder right now, over here to align with the runway. And left flight controls, now leveling off. We're gonna be having also landing gear down as we are approaching, and some flaps over here. We can decrease also the airspeed like this. So we're gonna be having also the view, the outside view for approach and landing, as you can see. A little bit more airspeed. So we need to align with the runway, with which we have some side wing, you can see, and some wind gust. Increase also the rate of descent. Now we use right rudder to align again with the runway, and cross controls because we have side wing and wind gust. So we have 1 more minute left for approach and landing. Use a bit more airspeed as we are approaching. We have 30 seconds to touchdown because the video will end. 20 seconds. Idle thrust now. Pitch down the aircraft, so we're leveling off for the flare now, couple of seconds. Also we need to keep center line with the side wind and the wind gust. So we're gonna be having the flare in a couple of seconds. Use idle thrust over here for the flare, aligning with the center line again one more time. So this is a beautiful flare over here, as you can see. and touchdown. Very beautiful, very professional, aligned with our center line. I use parking brakes and idle and thrust reverse right now. Full thrust reverse to slow us down, as you can see. So we made a magnificent landing, as you can see over here. We use thrust reverse to slow us down. So you can see all the landing gear here is perfectly safe. There is no breakage of any part of the landing gear.